So for this video, I wanted to go over how to solve projectile problems. The first problem I'm going to do is just a projectile that is launched parallel to the ground. And if we have time in the video, I'll handle how to tackle projectiles launched at an angle. Otherwise, that'll just go on a different video. Okay. So let's say we have, let's say we've been commissioned to find out whether or not a car was speeding as it went around a bend or something. It basically, was the car speeding as it went off a cliff? So what the heck is V naught? And we know that we can model the car as a single point. So here's our cliff. So the car is going to move forward. So we're going to model it as a point. We're not going to worry about the volume. That car should be experiencing free fall as soon as it leaves the cliff. So it should fall down and it should speed up as it falls. But it should only speed up in the Y direction. And remember, if it's going horizontal at the beginning, there's no vertical component there. So we know we can say the initial component in the Y direction is 0. So my trick, the way I handle projectile problems, is to keep my data separate, keep all the horizontal stuff separate from the vertical. So let me show you how I do that. One thing I do, I set up a T-chart just to keep 2 lists of all my horizontal stuff. So all the horizontal, we'll say that's the x-axis, and one side for all the vertical, and that is the y-axis. So hopefully right away we can see that what we are asking for is the horizontal velocity of the car. Now, the reason why I'm keeping these separate is because we have 2 different motions. In the horizontal axis, we have a constant velocity. And since there's no acceleration there, our equation for the horizontal simply looks something like this. So for the horizontal, we really only have 3 variables. So while we may not have seen this car go off the cliff, we probably know where it landed. And the distance that a projectile travels, we can refer to it as the range, like if we're talking like a shooting range or down range. So that is the horizontal displacement here. So let's say we're given that. Let's just call it we'll say D. But we didn't watch this thing in the air, so we don't know how long it was in the air. But we can measure the height of the cliff. So maybe that could help us. So if we can estimate the height of the cliff, so we'll say that's H. Let's take a look at our vertical. Anytime that you are missing a variable, like maybe you're trying to solve for something and you just don't have enough information, chances are you need to use the other list, and that's why the vertical here is going to be helpful. So in the vertical, we're experiencing free fall. So that means all of our kinematics equations apply. That means all of our variables are going to apply. So we're not going to have just one speed. We'll have an initial. We'll have a final. We will have a vertical displacement. Well, maybe. We'll have a time, and we'll have an acceleration. We already noted earlier that the initial vertically is 0. We already said we can estimate the height of the cliff. Maybe don't know how hard the car landed, so we can't get like a final vertical velocity. But we do know we're on Earth, so the acceleration is g. So let's not lose sight that we're looking for the horizontal velocity, and we should just be able to do d over t, but we don't have the time that the car was in the air. We weren't here for that. This is where the vertical comes in. Keep in mind that for the time the car's traveling forward in the air, it's also been falling. These two times have to be equal to each other, or else somehow the car is moving forward while in free fall, yet it's on the ground. That can't work. So these two times have to be equal. So we actually have enough information over here to get a time, because we don't care about the final vertical velocity. So we can get that time, plug it in over here, get that from the vertical, and then we have our horizontal velocity. Another thing I could ask for, maybe I want the final speed that the car strikes the ground with. So I want this speed right here. Well, if I've found my horizontal, and all I would need then is my vertical, and I could do Pythagorean theorem. Well, I would suggest picking a kinematic equation that doesn't use the time to get our final vertical. The reason why, if we round or if we get our time wrong, that will affect our final vertical velocity. So I would just pick a new kinematic equation that doesn't depend on time to get this. And now that we have both of those velocities, we can get our final speed. We can use inverse tangent to get the angle, and we can know our actual final velocity of this car. And that's it for projectiles that are launched horizontally. I'll start the angled launch with the next video.